Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem. And folks, we're going into one of the really interesting segments, or sectors I should say, of the industry here. Very interesting company called Revolution Analytics, and as you may know, they focus on R and really hardening R. So this is going to be some cool stuff. We're going to hear from Michael Helbron of Revolution Analytics. So Michael, show us what you got.
Thank you. So today what we'll see in the demonstration is a full lifecycle analytics project. For that, we're going to be looking at a fictitious telco company, BDBA Cellular, and really looking at how they would go about improving customer retention. So I mentioned that this is a full analytic lifecycle that we're going to cover as part of the demonstration. That includes everything from building out the models, passing that over to a business analyst that may consume the model predictions and make sense of those, all the way through to surfacing analytics to the end user through a website. And the end goal of this is really to make use of our data to enhance the relationships with our customers. We want to be able to provide relevant content to them. We want to keep them satisfied and keep earning the business. And the star of the show is going to be Revolution R Enterprise. This is our product. The key point with the product is it's R-based, and we can make use of any size data set with R. We can also make use of multi-node clusters, lots of different platforms. So regardless of what the data volumes look like, many different platforms will support. And with that, let's jump over to the demonstration. Okay, so for our fictitious cell phone company, I'm going to log into the website. And because we're going to have analytics surfacing in the background, I also have an event console which I can pop open. And this event console will allow me to start looking at the web services calls that are passing through the web page under the covers. So when I log into this web page, we'll see that we've got current products listed. We'll see that we've got offers to upgrade equipment. We'll see what the current balance is. There's also some offers that are being surfaced to us. And if we look at that event console under the covers, we'll see that there's some calls that have been passed in. So we've looked up what the account balance is. We also have some results of predictive models. So am I likely to churn? No, I'm not. In this case, I'm a satisfied customer. I also have a high lifetime value, can see my cluster membership. And based on the fact that I am a good, loyal, happy customer, I'm getting offers that are cross-sell, upsell sorts of offers. Hey, you're not really using all of your data. Would you like to switch over to a lower rate plan? Or we notice that you're using your phone a lot during work hours. Here's a coupon. Do you want to buy a Bluetooth headset? Now, if I was somebody that had a high lifetime value, but I was likely to churn, I'd have very different offers that are being surfaced to me on the website. And that's really the benefit of analytics, where we can start to tailor the content, have more relevant, personalized experiences with our customers. So in the case of this particular telco, big data volumes, everything is stored out in a Hadoop cluster. And I've got a cluster out there. It's running, in this particular case, CDH4, so we're on a Cloudera distribution. And I've got a bunch of data that's out there in HDFS. So we could take a look at what's out here, and got all sorts of stuff in my cluster. But what we're interested in here is this churn data set. We're going to be doing a supervised learning technique where we look at past data, looking at customers that have left us, and try and figure out why and use that to project what's going to happen into the future. So I mentioned that Revolution is R-based. Right from the shell, we are able to open up an R session right on the Hadoop cluster. And R is an interactive tool, so we could start typing things in, get the responses back right away. R is also something that's normally single-threaded. So when it comes to using something like a Hadoop platform, normally you'd be writing MapReduce in order to make use of Hadoop. With Revolution, because we have algorithms which have been pre-parallelized, we can work right out on the cluster. And we've got all sorts of algorithms. They're normally prefaced by an RX. So if I want to do something like get variable information about that churn data set, I could do that and just pass in our file that's stored out there. So I mentioned it's a supervised learning set. So we've got this flag as to whether folks have churned in the past, and we've also got a bunch of potentially explanatory variables. So is somebody sticking with us or leaving us, based on the fact that they have promotions or offers on their account? Did they buy a smartphone and then they're not really using the apps, or they're getting poor battery life? Are they having lots of interactions with us, lots of drop calls? So all sorts of things that might potentially be explanatory. And I could do the modeling right here, right from the console, but for a little bit better user experience, we also offer an IDE. So right from my laptop, I'm able to go and connect over to the Hadoop cluster. And this is going to be similar in workflow. We have this console window, but we also have some other windows here. So in our console, I could type things in interactively and get the results back. I could create variables. Let's say I want to create vector from 1 to 100. Once I start storing things into memory, I also have this object browser where I can start looking at what's been stored out there. I can look at all of the analytical packages which have been loaded into my session, all of my different scripts that are out there. And what we want to do is go through and model against this data set. Now, problem is I'm working off of my laptop, so my compute context here is local. In order for us to work over in the Hadoop cluster, we need to tell it how to connect to the cluster. And this would be true if we were working in any other sort of compute context too. Revolution salutes a variety of different grids, various flavors of Hadoop distributions and EDWs. So connecting over to Cloudera, I've set a couple of breakpoints in here. So when I click off in the margin, I can set a breakpoint. And when I go to start running through my code, it'll snag on that breakpoint. So the first thing I want to do is tell it how to connect over to my cluster. And we're going to set our compute context over to Cloudera, which means that we're going to pass in all of the stuff necessary to connect. So my username, the IP address of the cluster, some credentials to be able to authenticate, and then where my data is going to be stored out in the share directory there. After I've done that, I look over in our status bar, my compute context is now set to Hadoop MapReduce, meaning that all of the Revolution code that I execute is now going to execute against that Cloudera cluster. So we need to point it to where the data sits, and we're going to be going off of this churn data set, which is out there stored in HDFS. We're going to tell it what we want to model. In this case, we want to model churn as a function of all of those potentially explanatory variables, whether their account's current, they've got a good battery life, they're using all of the different apps. And then it's a matter of going through and choosing an algorithm. Now, in this case, we're going to use a logistic regression. Our churn variable is a yes or no decision, whether or not somebody has left us in the past, and that's exactly what would be output with a logistic regression. Now, I'm just calling a regular function. I don't have to do any of the parallelization for the cluster. What's going to happen when I start to execute it is my R engine is going to go busy. It's going to say he wants to run a logistic regression. He wants to do in a Hadoop compute context. So let me bundle up this job as MapReduce code. I will insert it into the job tracker, and then Hadoop will execute this as part of its normal process where the job tracker will start divvying up the task across all of the data nodes that are out there in the cluster. And this runs like any other task on the cluster. If I actually click over to the Hadoop admin page and refresh this, we can see that we now have a running job out there with my username coming from Revolution. We finished up the map phase and moving on to the reduce phase and have completed that. So going and starting on our second iteration here, logistic regression normally will go through a couple passes, however many you allow it to with the number of iterations, so it can start to converge. And when it wraps up, it will return the results straight to us from that Hadoop session. So the real advantage of using an approach like this, besides being able to deal with enormous data sets, besides being able to parallelize it across a cluster, is that for the analyst, for the R programmer, they don't have to explicitly roll their own algorithms and do the parallelization themselves. They would call a function just the same way as if they were modeling locally. We have a number of different algorithms that have been pre-parallelized. We refer to them as PEMAs, or parallel external memory algorithms, indicating that they'll operate in parallel as well as off of data on disk. And for this sort of scenario where we're looking with a binary output. We could deal with a logistic regression. We could deal with decision trees. We could deal with decision forests. I've already gone through and run a decision tree and brought the results back locally. When we're dealing with a logistic regression, what we're going to end up with is an output formula where we've got regression coefficients, and it's just going to be, y is equal to something times x1 plus something times x2, and we've got all those coefficients displayed. The model objects are going to be very different, though, if we do something like a decision tree. If I pop this up here, we also have a tree viewer. So depending upon the algorithm that you use, you will have different outputs that are available. Something like a tree viewer can also be really nice because we can start to click on any of these terminal nodes and see all of the rules that might come into place for why somebody might churn and leave us as a customer. Obviously, this is great for churn, but if you're doing something like fraud analytics, it can also be used for automated rule discovery, where we could start feeding these fraud scenarios into a business rules management system rather than waiting for fraud to occur and then adding a rule after the fact. So lots of different algorithms, and various ones are going to be appropriate for the different sorts of modeling tasks that are out there. Once we've decided on an algorithm, though, then it's time to actually start to do something with it. And I can have a logistic regression equation. I could go and score a data set. But when I log into the website as an end user, I don't expect to see my churn score there. I expect to see actions as opposed to insights. And if we save off our model object, this churn logit object that we've saved, well, now I, as the R programmer, can transition this to a different persona. I could pass this along to a business analyst that might be in a BI tool like a Tableau. And Tableau, if we look at this workbook here, we've got all of our dimensions and measures, so our app usage, battery life, all the things that we looked at in the past. We also have this flag here called churn prediction. And with Tableau, one of the things that they recognized is that they needed to have more in the way of analytic content. And we can connect over to R via Tableau. And once we do that, we're able to run scripts and have calculated fields. So now, in addition to all of their normal functions, there's all these script functions in place. And these script functions will go out and reference our code. So I can start to bring in this churn logit model object, and I can start to pass in arguments from within my BI dashboard. What then happens is I'm able to score these. So if I am bringing in multiple models and I'm trying to look at relationships across cluster membership, across churn prediction, across lifetime value, across RFM, across any sort of thing that I might be scoring out there, the business analyst, without having to do much in the way of coding, they can just bring in the code, but they can start to look for the relationships visually and figure out, well, what sort of offers do I want to surface to this end user? So what we saw today was really a full lifecycle analytic application, everything from building out the model in R right on a Hadoop cluster to transitioning from the R programmer over to a business analyst to be able to consume the results, develop whatever sorts of rules would be implemented, and then pass things over to a web application where through standard RESTful web services calls, we're actually able to surface offers in real time to customers as they log in. So thanks for your time today. That wraps it up for the demo.
That was some pretty cool stuff. So you're covering a large amount of territory here, right? That's, I guess, the key is that you're trying to enable very rapid fire development of rules, models, and then apply them in the real world and do so in such fashion as you can use things like Hadoop to do your heavy crunching, right?
That's exactly right. I mean, for a long time, analytics was kind of confined to the back office where somebody would get a one-off project request. They'd grab a sample of data and they'd generate some sort of report. And as analytics has grown in the marketplace, the most value that people get is when you can find the most leverage. And that means having analytics embedded into a business process. So it's not just statistician in the back office anymore. It's that statistician, it's IT being able to set up a big data environment, it's business analysts being able to put the results, it's front-end developers being able to, to bake it into the website.
Yeah, you can see why there's so much talk about a shortage of qualified, skilled professionals to do this stuff, because it is pretty complicated. Now, a lot of companies are doing training. How do you guys handle that? Obviously, you do support, and you have this product, this sort of marshaling area for designing models and deploying models, et cetera. But how much training do you do, or do you focus just on consulting?
We have a services arm that does both consulting and training. There are a few dozen classes that are on our books. Some of these classes are for users of legacy product to sort of come over and make the transition to R. Some of the products are dedicated to Revolution's products or just parallel analytics in general. And some of them are just general open source R related. There's also lots of great content that's out there on the web where people are able to get started for free with statistics.com or Udacity or Coursera. Just a million references to be able to get started with R.
Yeah, that's great, and Coursera is great stuff. I've checked that out myself. Well, folks, we've been talking to Michael Helbron of Revolution Analytics. This is fantastic stuff. Thank you so much. All right, guys, that concludes our webcast for now. And yeah, we'll catch up to you next time, folks. This has been part of the Big Data Ecosystem at InsideAnalysis.com. Take care, folks. Bye-bye.